Hello friends, so welcome in the new video. In this video we will again use EEPROM and I2C interface. We will write some data on EEPROM, but this time instead of Nucleo 144 board, uh, I'm using Blue Pill board, which is very compact STM32 bit series microcontroller, where with the cost around less than 500 Indian rupees, you can purchase this hardware from any online stores and you can do this experiment. This EEPROM is also hardly you can purchase under 400 rupees, and this Arduino is also very cheap. But if you don't want to use this hardware Arduino, then you can also go for this type of connector, right? Because the purpose of the Arduino in this experiment is only and only to display UART message. Because on this blue pill board we don't have any port available on which we can display our UART message. So that's why I use this Arduino. Otherwise, you can use this type of RS232 connector, USB to RS232. You can directly connect this USB with a PC. From this blue pill board, we have only 3 wires, which is EX, RX, and ground. So you can use pin number 2, 3, and 5, if I'm not wrong. And you can directly connect this wire with this RS232 connector, and you can directly connect this USB with your PC. On your PC, using any terminal software like RealTerm, TerraTerm, you can display this message, right? But today I'm using this Arduino. Okay, so here you can see the connections are like B6, a blue pill is connected with SCL, B7 with STA, supply with supply, ground with ground. Then the A9 with RX Arduino, A10 with TX Arduino, ground with ground. So now these pins are from these connections, right? So you can see the B6, B7 are for I2C, A9, A10 for serial. So you can see B6, B7. So here I2C SCL, I2C SDA, and A9 is serial TX, A10 serial RX, right? So these 4 wires are connected, and other 3.3 and grounds are also connected. So here in this image you can see this is my actual photograph of my setup, and I'm going to display this also in while I will running this. So this is the EEPROM, this is the blue pill board, this is Arduino. Connections are like 4 wires are connected with this Arduino with this UART. Okay, so these are the connections. Now again I would like to tell you that don't use this jumper wire until and unless it is just temporary setup, because here what I observed that because of this jumper wire sometimes this setup gives some garbage values, right? And because these jumper wires are very loose, that's why I'm getting this type of garbage values. So if you have a proper application for which you want to develop this, then it is better to use breadboard or at least use some other good connectors. And if that will be a permanent setup, then it is better to use direct soldering, right? But since this is for the experiment purpose, so I use jumper wire. And again, because of this jumper wire, sometimes I am getting some garbage value, but after say properly press all the wires, I'll get the message. So don't worry about that. Now this is the logical structure of EEPROM. So I already discussed this in my previous video, so I will not going to repeat this, but just remember this uh, setup as a white page. Okay, and let us say you have one white page with you. Just draw different rows, different column, and consider here this setup. This page is having 1024 rows and 8 columns. So on each row you can write 8 bits, and total 1024 columns are there. So you can write 1024 into 8 bits. And if you convert these bits into byte, then you can write 1024 byte. And 1024 byte means 1 kilobit. So if you have a single page with this setup, then you can say your EEPROM size is 1 kilobyte. If you have 1024 such pages, then you can say your memory size is 1 megabyte, right? If you have more 1024 pages in that each 1024 page, then your memory size will be 1 gigabyte, right? This is how you can calculate the memory. But for now, just consider this EEPROM as a single page. And now each location has its own address. So address 0, address 1, address 2, and as you can see, each location store 8 bit. So let us say if you want to store this message hello, then each digit will display using 8 bits. So first location will store H, second location will store E, third will store L, then L and then O. So from address 0 to address 4, you can save this message. Okay, with five different addresses. Now next message should be from address 5. Okay, so this is how you can save the message. Now again I am using same program, but this time I will write some part. I will use this write EEPROM and read EEPROM as it is. So I already discussed this in my previous video, but let us go through this quickly. So again, in this whole function, the important part is this HAL function, HLI2C mem, right? HLI2C mem read. I'm not defining this function. These are already defined by this HL library. I'm just calling these functions, right? So one is for write I2C, one is for read I2C, and each function is having 7 different arguments. The first argument is your I2C handler, second is your I2C address, third is your memory address. Now what this I2C address means, let us say you have one board and 6 different I2C memories are connected, EEPROMs are connected. So first you have to specify that on which particular EEPROM you want to write, and for that you have to select the hardware address. Whatever EEPROM is there with you, you have to have the hardware address of that particular EEPROM. Now after this, you have to specify the memory address. So memory address is nothing but this location, right? So third argument is memory address. Fourth is the scheme, how you will use this I2C mem address size. So I'm just using size 16-bit. Now next two arguments are very important in this function, and these are data and size. So whatever data you want to write, you have to specify, and whatever size data. Let us say your data is hello world, and if you want to write only one H, so you have to define size 1. It will only write first digit, right? So your data and size are very important parameter in this function. And last one is a simple argument, simple count. So you can increase this number if you have some skipped message, or you can say half. If you are observing that your message is not complete, so you can simply increase this number, because this indicates timeout after this much tick, right? Now if this function will execute properly, it means that if the required memory is available with your hardware, so this will going to return HALOK. And if this will return HLOK, then it will call this function simply. And if this will not return HLOK, then this will call this function. And now in both the cases, this is common function. This is HLUR transmit. So if this message is returning at not equal to HLOK, it means either the memory is not there, either some wire is loose, either some connection is not proper, either you are providing wrong memory address, whatever things are there. So it will simply load this I2C transmission error message into this UART buffer, and it will display same message on UART. From UART, you will observe that something is wrong and you will get this message I2C transmission error. If the function will return HLOK, it means that everything is perfect. So this line will execute, and this line is actually copying message return, whatever message you have written, it will copy this into a UART buffer, and UART will display that part. So on UART, you will observe message return and your message, whatever message you want to write. Same way, this is for I2C mem write. This is I2C mem read. Arguments are same, more or less, but the only difference is this time this data will be your received data. So here, whatever data you want to write, you have to specify that data. Here instead of data you have to specify the variable where you will going to save the message and size of the message. So how much byte you want to save? 5 byte, 6 byte, 6 byte, 7 byte, whatever. Right. So in this second part, your data is actually your received variable where you want to receive your message, where you want to store your message. Okay. So here you can see both the functions are having same argument, memory address, data and size, memory address, data and size. The only difference is your data should have proper message. Your data should be your variable where you want to store the data. Okay. And here again, if this will return HL, okay, then it will simply display message received. Whatever message it will receive from this, but whatever address you have provided, it will display same message. Otherwise, it will display I2C reception error. Same. All right. And now I will simply use this function as it is. So I'm not going to write this again, but let us build the project. And you have to remember this part number 103C8. Right, this is the hardware. Just giving any name. And now, as per the circuit, you have to use two hardware. One is your I2C, one is your serial UART. That's it. Okay, and crystal is also required. So simply right here you can see this is system. Yes, crystal, select crystal. Now here connectivity, select I2C. Now you have to remember the I2C pin should be B6 and B7. So just check this should be B6, B7. Otherwise, these pins are also provided the same I2C. But we are selecting this, and same way for UART A9, A10. So simply select UART, synchronize. You can A9, A10. So I just configured three things: I2C, UART, and crystal. One more thing, UART, you have to change the baud rate. Okay, and now generate the code. Now you have to double check this baud rate, because many times what I observed that even if I configure 0 in this generated code, it is taking double all this. Right, so just check the baud rate, and now you can see even we change this, but it is again. So I am just changing again. Save this. Now I will going to use this as it is. Okay, and it should be outside of the main, because these two are functions which we will going to call as per our requirement. Okay, transmit and receive. Now one thing which you have to observe, that some, yes, your buffer variable is missing. So declare this as well. Character your buffer, let's take value 50, maximum 50. Right, it will only store this much, because in our experiment it is not it will not store more than 50, you can say, character, right? So I'm just taking this. You can increase this size as per your requirement. And now let us start with the define part, because here you can see in this function I'm just taking this I2C address as it is. I'm just defining this somewhere over here. Define and our address is, I think, 80, right? Yes, 5080. So you can write 0x50, or we can directly write 80 as well. Second thing, I would like to define my message, right? Message I2C EEPROM paste on loopy board, right? This is my message. Now to store this, we have to declare two variable. Type is uint8. One is tx data, and where I will going to simply load this message, and one is rx data, right? And the size is size of the message, simply, right? Size of the message, and I'm just loading 0 value, right? So this is the declaration part. This is my data, and now I'm going to use this function as it is in my program. So in main, outside of the while one loop, I will call this function to store some data on my EEPROM, this function to read the data from my EEPROM with some delay, random delay. It will be 100 millisecond. Now let us change this value from 0x00 will be the starting address for read as well as for write. It will read send message. This is the data. So you have to pass message, right? So let us pass simply a message, whatever message is there. And here size of message, size of message. And you have to simply typecast this to uint8. Okay. This is also important part. Now I'm just repeating this but it receiver side. But this time instead of message, I have to pass my variable name, which is rx data, right? If I'm not wrong, here this somewhere, yes, this is rx data. And again here it should be size of rx data. So this time it will read the data into this variable, right? Now let us just debug this code to identify whether any error is there or not. If error is there, we will correct it, and again we will re-debug it to make sure that our program is having no error. Right now I think 4 error it is showing. Why? Let us check. Yes, one thing is, yes, we defined we should not use this semicolon. One warning is there because we are using sprintf. We have to include stdio.h library, right? Debug it. Now showing 0 error. So let us keep the warnings for now and release the target. Now in property, you have to select this option because ultimately we have to upload a hexadecimal file So you have to generate hex file, release the target. Now in release path, you will see hex file. Yes, this is the hex file. Now I'm just copying this because I am going to load this on my hardware. I'm just copying the path, right? You can see. Now this is the updated hex file. Now to load the program on this blue pill board, we have to use this ST-Link utility. So we have already uh, know how to load the program. Okay. If you don't know, then just go to the previous videos. To select the hex file, first you have to select the board, connect the target. After this, we have to connect the target. Now target is connected, our file is loaded. Now simply I have to load the program using this button, right? Now this is the connection. These are the boards. You can see here. This is the memory. This is the board, and this is the Arduino. Now our program is already loaded on the board, right? So now I'm just changing this jumper from the running mode to programming mode to running mode. This is in programming mode, that's why I'm able to load the program. Now this is in running mode. Yes, you can see. Now open the Arduino terminal, because again this Arduino is having program which simply display whatever this Arduino will receive on the terminal UART. You can use RS232 connector as well. Okay. Now I have to simply check the jumper wires, reset the Arduino, and on the screen you can see I'm just opening the serial monitor, right? And now I will simply replace this, reset this board, and you can see you can observe the message I2C EEPROM test in blue pill board, right? So here this blue pill board is actually writing this message to this EEPROM. Again, it is reading back this message from this EEPROM. It is simply forwarding this message on UART, and our Arduino is simply receiving this, and same it is forwarding to the PC. So this is how you can use EEPROM and I2C on this blue pill microcontroller board, which is very cheap compared to STM Nucleo board. So this is what for the today's video. If you like my work, then please like my YouTube videos, subscribe my YouTube channel, forward these videos to your friend. In future, I will come up with more this type of advanced hardware, advanced interfaces. Thanks for now. Bye bye.